So today I will explain about techniques of differentiation. First of all, differentiation is a method used to compute with rate change of function fx with respect to its infinite x. This rate of function is known as the derivation of f with the derivation of f with respect to x. So the first technique is basic differentiation rule, which is we have constant rule, linear rule, power rule, and sum and difference rule. Sum and difference rule is the derivative of the sum or difference of function is simply the sum or difference of their derivative. Next is product rule. Product rule is used when functions are being multiplied. Next is quotient rule, which is it used when differentiating a function that is the quotient of two other functions. Next is chain rule. It used when we have a composite function. Last but not least, implicit differentiation is used when function is not explicitly so for one variable. And linear approximation is the linear approximation of a function. It's nothing but approximating the value of your function at the point using a line.
Next is question 2. In this question, we have two parts. So for the first part, we have to find the derivative of this equation. So when two functions multiply together, we use product rule. First step, we have to break into two parts. So ln x squared is u, and 10x minus 3 is v. So second step, we have to find individual derivatives. So to find u prime, we use log rule and chain rule. So when we 2 multiply 1 over x, and then we get the final answer is 2 over x. To find v prime, the derivative of 10 is sec squared. So we get sec squared x minus 3. Step 3, put it all together in the product formula. So all the value we have to put in the product rule product formula is uv prime plus vu prime. So line x square multiply on x square multiply sec square x minus 3 plus tan x minus 3 multiply 2 over x. So we have to put it on in the midway. So the final answer we get is line x square sec square x minus 3 plus 2 tan x minus 3 over x. So for the part B, we have to find the derivative of this equation. So we have fraction, one function divided by another. We use quotient rule. Step first, we have to break into two parts. So top is u and bottom is v. Step 2, we have to find individual derivative. So u prime, we get 2x, and v prime, we get negative sine x. Step 3, combine all together into the quotient rule formula. As you can see, the quotient rule formula is vu prime minus uv prime over v squared. So cos x multiply 2x minus x squared plus 1 multiply negative sine x over cos x squared. So step 4, we have to simplify the sign. Notice the double sign in the second part. Negative sine squared plus 1 multiply negative sine x becomes plus x squared plus 1 plus sine x. So when we just simplify the sign, the final answer we get is this.
For the question 3, find dy over dx using implicit differentiation. Okay, firstly, we need to separate it to 3, which is the first one is ln y, second one is cos square in bracket x square plus e power of y, and the third one is 2xy. Ln y we differentiate, it will be 1 over y multiplied by dy over dx. And for the second one, cos square in bracket x square plus e power of y, we move 2 to the front so that we get 2 cos x square plus e power of y. And then we differentiate cos, we will get negative sine x square plus e power of y. After that, we differentiate in the bracket, it will be 2x plus e power of y times dy over dx. After that, we rearrange, we will get like this. This equation, we need to multiply it with 2x and e power of y. The answer will be like this. After that, for the third one, 2xy, we will use product rule, which is u is equal to 2x and v equals to y. After that, u prime is 2 and v prime is dy over dx. We substitute into the product rule equation, and we will get 2x times dy over dx plus 2y. After that, we rewrite all the equation that we differentiate, and it will be like this. After that, we move the number with 2 dy over dx to the left side, and then the number without the dy dx, we move it to the right side. After that, we let dy over dx alone at the left side, and we move the number in the bracket to the right side, and it will be like this. And then we need to multiply by y so that we can cancel out the y at the 1 over y. So your answer will be like this.
So for the question 4, use linear approximation to estimate the value of 8.02 square minus 1 over square root 3 8.02. Correct to 2 decimal places. So the first step, you have to replace the number with x. So it becomes x squared minus 1 over square root 3x. Then the square root 3x, we fraction it and become x squared minus 1 over x power of 1 over 3. Then we rearrange it and it becomes x squared minus x power of negative 1 over 3. Next step, we differentiation the equation and it becomes 2x minus negative 1 over 3x power of negative 4 over 3. Then we rearrange and it becomes 2x plus 1 over 3x power of negative 4 over 3. Then the given value is 8.02. So the chosen value we choose from the question is 8.00. The delta x is 0.02. Then we use the equation which is fx naught plus f prime x naught delta x. Then we substitute the equation on the formula. The x we replace with the chosen value which is 8.00. The next step, we calculate and get the answer which is 63.82.